New Year's Eve, 1968. The Soviet Tu-144 is rolled out for its first flight. Soviet officials have promised the world it'll fly before year's end, beating its rival, the Concorde. With only hours to go, the race to become the world's first supersonic transport reaches a climax. The most common image of supersonic airline travel is the Anglo-French Concorde, which since 1977 has carried passengers from Europe to America in just over 3 hours. What is less well known is that the Concorde's Russian cousin, the Tupolev Tu-144, was the first aircraft of this kind to leave the ground. The first flight of the Tu-144 prototype took place on December the 31st, 1968. In many ways, it was a high point in a period of Soviet history where there seemed to be no bounds to the possibilities of scientific advancement. The Tu-144 was born out of the optimistic thinking of the post-Sputnik Soviet Union. It was another possibility for a major international first. But in fact, the Tu-144 project became a succession of triumph and tragedy. Civil aviation has always been important in Russia and in the Soviet Union. The great Soviet land mass makes the aircraft the perfect form of transport. In the early 20s, German Junkers aircraft carried Soviet passengers from Moscow to Gorky. The name of a bright young engineer, Andrei Tupolev, was already becoming prominent. Under the guidance of his mentor, Professor Nikolai Zhukovsky, the young Tupolev had made rapid progress. Zhukovsky recognized his talent and put Tupolev in charge of the equipment at his laboratory. That same laboratory became famous after 1918 when it took on the official title Tsargi, the Central Institute of Aero and Hydrodynamics. At Tsargi, Tupolev's genius was allowed to flourish. In the 20s, several successful aircraft were produced under his direction. They bore his initials, A-N-T, in their titles. This is the ANT-4. In the late 20s, Tupolev managed to satisfy Stalin's voracious appetite for industrial output. He was responsible for several aircraft of symbolic importance. The ANT-9 flew to Berlin, and the ANT-6 flew to the North Pole. Tupolev won favor with Stalin and was rewarded with his own design bureau. By 1933, the Soviet tradition of creating aircraft for national prestige had begun. That year, Stalin directed Tupolev to construct an aircraft designed to break the world record for endurance flight. The result was the ANT-25. This remarkable aircraft, with a single engine and a wingspan of 111 feet, had unprecedented endurance. It achieved its aim of breaking records. In June 1937, it flew from Moscow over the North Pole to the American state of Washington, 5,288 miles. A month later, it flew from Moscow all the way to San Jacinto in California, an extra 1,000 miles. The flight took just over 62 hours and was another world record. The Soviet leadership was well aware that world record-breaking aircraft were not necessarily practical. Andrei Tupolev also understood this. and was capable of responding to practical as well as propaganda briefs. In 1935, structural tests were being carried out at Tsagi for a new civil airliner. Tsagi had become one of the world's most substantial research facilities. It had a vast range of wind tunnels and structural test devices. The civil aircraft under test, the AN-T-35, would become the Soviet Union's first modern passenger aircraft. But other Soviet designers were more interested in the American Douglas DC-3. As a result of Boris Lizunov's enthusiasm, the Soviet government negotiated a license to manufacture the DC-3 in the Soviet Union. The DC-3 was modified for the extreme conditions of the Soviet climate. The result was the Lizunov Li-2. It had less wing area and less powerful engines than the DC-3. Speed was deliberately sacrificed in favor of greater range. Sergei Ilyushin's design bureau had produced the hero of the Great Patriotic War, the Shturmovik ground attack aircraft. His IL-12 and 14 civil transports had none of the Shturmovik's distinction, but they were the backbone of Aeroflot's fleet until 1955. In May 1952, the world's first jet airliner, the de Havilland Comet, began a service from London to Johannesburg. But two in-flight structural failures halted the Comet program. In America, the Boeing company was testing a swept-wing, four-engine jet demonstrator, the Dash 80. It was promising, and work began on an airliner version, the Boeing 707. The Dash 80 and its descendants would revolutionize air transport in the West. But the world's second jet airliner to enter service would not come from America. In the years after the Great Patriotic War, the Soviet Union threw itself into the jet age with all possible speed. Its first great breakthrough was in fighter aircraft with the enormously successful MiG-15. But Stalin's ambitions were larger. A great percentage of the resources of Tsagi was given over to the development of a long-range jet bomber. Ironically, attempts to develop a bomber capable of intercontinental nuclear destruction made possible a great leap in the field of civilian air transport. The Soviet Union always looked for a civilian application for its large military aircraft. Tupolev's Tu-16 jet bomber, the Badger, was a perfect subject for modification. Tsagi and Tupolev had learned much about the pressurization of large aircraft from the development of their B-29 copy, the Tu-4 Bull. Development of their own technology was rapid. From a situation where they lagged behind the West in both jet engine technology and the development of large, fast aircraft, they quickly launched one of the great surprises of modern aviation. In 1955, this new Russian airliner revolutionized Soviet civil transport. It was the Tupolev Tu-104, the world's first jet airliner in successful continuous service. Its impact within the Soviet Union was extraordinary. Flights that had taken 30 hours could suddenly be achieved in 10. In spite of the success of the pure-jet Tu-104, Andrei Tupolev was convinced of the efficiency of the turboprop as a means of achieving greater range. The Tu-16 jet bomber had provided the basis for the development of the Tu-104 airliner. The Tu-95 Bear, with its giant turboprops and impressive range, also had potential for conversion to civil use. The result of this combination of swept wings and giant turboprop engines was one of the most unusual aircraft the world has ever seen, the Tu-114 long-range airliner. In 1961, the Tu-114 entered service and became the backbone of Soviet international travel. It was a great symbol of Soviet prestige. Nikita Khrushchev was delighted when, on the Tu-114's debut trip to New York, the Americans couldn't find a set of steps high enough to reach the doors. Khrushchev had to descend to the tarmac on a ladder. After the success of the long-range Tu-114, Tupolev returned to the design of jet airliners. In the mid-60s, the Bureau began construction of what would become the Tu-154. It was tested in the massive wind tunnels of Tsagi. Tupolev is said to have stormed into the Kremlin in 1919 and demanded that Lenin establish an aerodynamic test center outside Moscow. In his late 70s, he still came to that test center, Tsagi, to oversee development work on his new jet airliner. The Tu-154 was developed to succeed the Tu-104 as the Soviet Union's premier medium-range transport aircraft. The Tu-104 had served well for 12 years, but by 1967 it was fast becoming obsolete. The Tu-154 began the second generation of Soviet jet transport. The challenge now was to keep pace with Western manufacturers like Boeing. The 154 was powered by 3 Kuznetsov turbofans. The 3 rear-engine configuration gives it a striking resemblance to the Boeing 727. Like the 727, the Tu-154 is still in operation today. Throughout the 50s, Tupolev's main rival in civil aircraft development was Ilyushin. Ilyushin only had moderate success with their IL-18. But in 1962, Ilyushin made a serious challenge to the Tu-114's monopoly on long-range international travel. At Tsagi, aerodynamic tests were being carried out on the IL-62, Ilyushin's new long-range jet airliner. The configuration of the IL-62 was similar to the Vickers VC-10. It had a long fuselage with 4 engines. They were arranged in 2 pairs, one on either side of the fuselage. Because the IL-62 was designed to fly international routes, ditching tests were carried out. They were intended to examine emergency characteristics if the aircraft came down in water. In 1967, the IL-62 entered service with Aeroflot. Its first route was between Moscow and Montreal. It carried a maximum of 186 passengers and cruised at more than 600 miles an hour. The IL-62 was featured at the 1967 Domodedovo Air Show, held to commemorate the 50th anniversary of the October Revolution. The aircraft's extremely powerful Kuznetsov engines gave it good short takeoff and landing performance. The power of the reverse thrusters could stop it after a landing roll of only 1,000 yards. Extremely good for such a large aircraft. It could take off using less than 2,000 yards of the runway, which is equally impressive. While East and West each made their breakthroughs in subsonic air travel, the race for a supersonic air transport, an SST, was quietly beginning. In the late 50s, the English Bristol Company designed a flying test bed for a supersonic airliner. In America, NASA made early wind tunnel investigations of the viability of supersonic transport. In June 1959, Lockheed emerged as the first American company to make a serious attempt to develop an SST. Lockheed engineers studied the problem of stall caused by the high angles of attack necessary for takeoff and landing. They found they could use a phenomenon called vortex flow to prevent turbulence at high angles of attack. In order to create the right conditions for vortex flow to take effect, they developed a unique wing design, the double delta. Vortex flow is a rotating pattern of air developed along the upper surface of the wing. This stable pattern of air prevents the loss of lift normally caused by turbulence when the nose is high for takeoff and landing, but it can only be generated by the right wing design. Lockheed's innovation was a small second delta ahead of the main delta wing, which improved the formation of vortex flow. Boeing's early SST design overcame the low-speed stall problem by using variable geometry. It was to be an all-titanium aircraft capable of reaching Mach 2.7. It was large with a wide body capable of carrying 300 passengers. This is Vladimir Myasishchev, designer of the M50 supersonic bomber known in the West as the Bounder. As the Soviet Union became interested in the idea of an SST, the M50 was considered for a role in civil aviation. The possibility of a passenger variant of the Bounder was examined, but never went beyond the planning stages. Vladimir Myasishchev was increasingly seen as flamboyant and unrealistic, and in many ways the Myasishchev aircraft shared this personality. Khrushchev eventually lost patience with Myasishchev and stripped him of his design bureau. When the M50 made its debut flypast at the Tushino display in 1961, only top Soviet officials knew that Myasishchev was finished. With Myasishchev gone, responsibility for the design of the Soviet SST passed to Andrei Tupolev, the old man of Soviet aviation. Nikita Khrushchev admired and respected Tupolev for his experience and accomplishments. Tupolev's Crimean dacha was only a short walk from Khrushchev's summer home. The legend is that the Tu-144 supersonic transport was born in the course of a conversation between Khrushchev and Tupolev as they walked on a Black Sea beach. Tupolev's son, Alexei, was appointed its chief designer. At Tsagi, the Tu-144 design was subjected to the most comprehensive wind tunnel and aerodynamic testing program in the history of Soviet aviation. The process did not begin well. Early meetings at the Tupolev Bureau had favored a tailless design with a delta wing. This configuration was not received warmly by aerodynamicists at Tsagi. Tsagi was suspicious of tailless delta designs. They'd once issued an edict requiring separate tailplanes on all Soviet aircraft. A major struggle followed, in which Tupolev needed to use all his years of experience of Soviet politics and power. By the beginning of the 60s, he had prevailed. Even the strong Tsagi establishment was forced to give way to his experience, reputation, and insistence on a tailless design. Although the tailless Delta was not popular in the Soviet Union, it had a long tradition in the West. The German designer Alexander Lippisch had experimented with it in the 30s, and so had the Horten brothers. The tailless Delta was a popular subject for experimentation among the Western military after the war. America had the Convair F-102 and F-106 interceptors, and Britain had the long-lived Avro Vulcan, the world's first delta-wing jet bomber. There is speculation about the degree to which Tupolev was influenced by these Western military aircraft in his Bureau's SST design. And there's also the question of how much he knew about the other supersonic transport projects already underway in Europe and in America. When a model of the Soviet SST was shown in Paris in 1965, the similarity of shape to Western SST designs was remarked on. But the French designer Marcel Dassault pointed out that there was bound to be a resemblance. The Soviet brief to design a fixed-wing SST capable of Mach 2 was identical to that of the West and would naturally evolve in a similar way. In any case, the project continued to be accused of industrial espionage and impropriety. But in spite of the similarities between the early Western SST concept and the Tupolev 144, they differed in many ways. The main difference was to do with the development of the engine inlet ducts. For an engine to operate efficiently at supersonic speeds, air entering the jet intakes has to be slowed down. The most difficult challenge faced by the Soviet engineers was to develop a series of airfoils inside the jet intakes to reduce the speed of the air. More than half the wind tunnel testing carried out on Tu-144 models was concerned with this problem. Another challenge facing the engineers at Tsagi was the unpredictable nature of airflow at constant supersonic speeds. It was a new problem. Soviet supersonic fighter aircraft remained supersonic for only a short period of time, but the Tupolev 144 would fly beyond Mach 2 for hours. The airframe had to be built to withstand damaging shock waves generated by sustained flight at twice the speed of sound. The integrity of the structure was thoroughly tested. By 1967, the prototype of the Concorde, a British and French collaboration, was taking shape. In America, the major SST designs were still in the theoretical stage, and it was becoming clear that Europe and the Soviet Union were the only real starters in the SST race. It was also becoming clear that the economic benefits of supersonic transport were exceeded by potential national prestige. The Anglo-French partnership was unique. The British Aircraft Corporation and the French company Sud Aviation designed the airframe. The French Snecma company and the Bristol engine division of Rolls-Royce collaborated to develop the Olympus engine. A British Avro Vulcan was modified as a flying test bed for the Concorde's Olympus 593 engines. At the French Zéat laboratory, different alloys were exposed to the thermal conditions the aircraft would generate at high supersonic speeds. Liquid nitrogen was used to simulate the rapid cooling effect of deceleration. At Sud Aviation's Ground Systems Laboratory at Toulouse in France, an elaborate flight simulator was created to duplicate the flight characteristics of the Concorde. The simulator allowed training and experimental flights to be made in a variety of mechanical, climatic, and visibility conditions. A closed-circuit color television system gave the pilot an image of what was in front of the aircraft. It originated from a detailed model that was scanned by a television camera. The simulator analyzed the effect of the pilot's actions on the flight and control systems. Soviet interest in the Concorde simulator was no secret. Its designer, on an official visit to Moscow, was repeatedly asked by a Soviet official whether it could be adapted for the Tu-144. In the Soviet Union, Andrei Tupolev and his son Alexei were under tremendous pressure to get the Tu-144 into the air before the Concorde. After careful examination of more than 100 different configurations, a final design was settled on and construction of the first prototype was well advanced. The Tupolev Design Bureau did not hold a complete monopoly on the construction of the Tu-144. The Ilyushin Design Bureau, Tupolev's main competitor in civil aviation, was involved in the construction of the airframe. The Antonov Bureau, based in Kiev, helped build the wings. In the Soviet Union, there was an abundance of titanium, and Soviet engineers applied it skillfully to the Tu-144 design. It was used as a symbol of their technical achievement. When French officials visited a Tu-144 assembly facility in 1967, they were presented with a titanium samovar. Soviet designers sought information about Western landing gear. The head of Aeroflot Paris entertained French maintenance workers at expensive Paris restaurants in exchange for tire debris from runways. In 1965, he was expelled from France. By late 1968, the Concorde prototype 001 was almost complete. 6 years had passed since the formal agreement between Britain and France had been signed. Since then, the project had come to symbolize the possibilities of European cooperation. Many Europeans thought Concorde would break America's hold on civil aviation, restore European prestige, and revitalize its struggling aircraft industry. Prototype 001's first move was a crawl across the airstrip of Toulouse for its variable geometry nose section to be installed. It carried with it the greatest of expectations from the whole of Europe. An essential part of Concorde's design was its movable nose. In the production version, this solid visor would be replaced with a transparent one for greater visibility. British and French designers had much to be proud of. Their aircraft had state-of-the-art electronics, heat-resistant aluminium alloys, and complex engines capable of propelling it well beyond Mach 2. But it was yet to fly. And away to the east, there was a genuine competitor. On the 31st of December 1968, the Tu-144 prototype was towed from its hangar at the Zhukovsky Flight Test Center outside Moscow. There had been a week of poor weather, but on the last day of the year, the clouds broke, and it was cold and sunny. At the 1965 Paris Air Show, the Soviet delegation had announced that the Tu-144 would fly before the end of 1968. This was the last chance to make good on that ambitious promise. But there was no intention of giving this historic event any pre-publicity. It was held in secret. If there was an accident, there need be no announcement. Andrei Tupolev's son, Alexei, was the chief designer of the Tu-144. Andrei, now 80 years old, was accustomed to first flights. In a long career, he had seen 120 aircraft from his bureau fly for the first time. Now, with his son, the heir apparent to the Tupolev dynasty, the patriarch of the Soviet aircraft industry, prepared to watch another Tupolev first flight at Zhukovsky. The Tu-144 prototype had a crew of 4. The chief test pilot was 42-year-old Edward Elyan. The flight engineer was Yuri Selyverstov. Vladimir Benderov was leading test engineer, and Mikhail Kozlov was co-pilot. Kozlov and Benderov were entering the prototype of an aircraft that would kill them 5 years later in a mysterious crash at the Paris Air Show. At this stage, the prototype was not pressurized, nor was it fitted with any of the amenities intended for the production version. Edward Elyan was one of the most experienced test pilots in the Soviet Union. He and his crew were well aware of the risks involved in flying a complex new aircraft. In spite of the hundreds of hours in wind tunnels and all the thermal testing and simulator training, there was a great deal of uncertainty in a first flight. Elyan announced that the Tu-144 was ready for takeoff. Permission was granted. The takeoff was smooth, and the Tu-144 became airborne without incident. Data from the flight recorder began to flood into the ground monitoring stations. A modified MiG-21 known as the Analog had been used to test the wing shape of the Tu-144. It now acted as a chase plane on this maiden flight. The great designer and his son and heir watched the results of their years of work. After the aircraft leveled off, the variable geometry nose was raised for the first time. Edward Elyan told ground control that the raising of the nose had been successful and he would now bank the aircraft. There was no intention for the Tu-144 to go supersonic on this flight, but to those watching, the potential of supersonic airline flight seemed to be within reach. This aircraft should be able to leave Moscow at noon and arrive in Montreal at 9 the same morning. A flight from Moscow to Delhi would take less than 2.5 hours. The SST would also have great value within Soviet borders. The Soviet Union covered a vast area, and travel time between many cities was great. An operational Tu-144 would be able to reach major Soviet cities as far away as Khabarovsk in half the time it would take a conventional jet airliner. In spite of the excitement at the success of the initial flight of the Tu-144 prototype, many Western analysts were to argue that its debut in the air was premature. Their opinion was that the ground testing program had been cut short because of political pressure for the Tu-144 to fly before the Concorde and to make the flight as promised before the end of 1968. In any event, the first flight was a success. The flight control system operated well. The mechanism to raise the nose worked exactly as it was designed to do. Now, as Edward Elyan made his final approach, he lowered the nose to increase visibility. He lined the great machine up with the Zhukovsky runway and brought it in over the crisp December snow. The first flight lasted 38 minutes. Andrei Tupolev watched every one of them with the greatest attention. The landing was perfect. The ambitious promise made in Paris in 1965 had been fulfilled, if only with a few hours to spare. The idea for a Soviet supersonic transport had been inspired in a period of great optimism that followed the successful spaceflight of Yuri Gagarin. Now the Soviet Union enjoyed another first. Years of testing had been justified. Soviet prestige had been enhanced. The flight crew members and the Tu-144 design team were acclaimed as heroes. But there was little time for jubilation. The Soviet designers faced the next stage of the task. They had to make the step from prototype to a practical and efficient operational aircraft. It was a step that neither the flight crew nor the great Andrei Tupolev would ever see. Although the Soviet SST was the first in the air, the French and British were not far behind. On the 2nd of March 1969, the Concorde prototype 001 made its first flight. At the Concorde rollout ceremony at Toulouse, British and French officials spoke of their successful cooperation in designing and building the Concorde.
And behind this great achievement lie the work of tens of thousands of dedicated scientists, engineers, designers, managers and work people from both our countries.
The first flight of the Tu-144 had been carried out in secrecy, but the Concorde rollout was conducted with great ceremony. It was a celebration of advanced technology and an expression of what could be achieved by international cooperation. On the 5th of June, 1969, just 3 months after the first flight of the Concorde, the Tu-144 prototype made its first supersonic flight. It was another first for Soviet aviation. This is one of the 8 production Tu-144s. It is now retired at the Monino Air Force Museum outside Moscow. The first production model was revealed in August 1972. The production Tu-144 was longer than the prototype, and it was larger than the Concorde in every dimension. Its wingspan was 12% greater. It was 7% heavier. There had been handling difficulties in takeoff and landing. To cure them, the designers resorted to installing retractable canards, small wing surfaces, in the fuselage just behind the cockpit. The wings had been changed. Their curved ogive-shaped leading edges were now a straight-edged compound delta. The engines had been moved farther apart to improve stability, but they were still much closer together than the Concorde engines. The Kuznetsov turbofans were not efficient at supersonic speeds. Afterburners had to be used throughout the flight to give enough thrust. Fuel consumption was increased. The Tu-144 burned more fuel and had less range than the Concorde. The feared Soviet long-range supersonic bomber, the Tu-22M Backfire, used the same engines as the Tu-144. In 1972, Soviet designers approached the British electronics firm Lucas. They wanted to buy a sophisticated digital fuel control system for the Tu-144. Such a system could help solve the fuel efficiency problems of the Kuznetsov engines. The British government, fearing a military application of the Lucas technology, blocked the deal. Andrei Tupolev died on December the 23rd, 1972. He was 84 years old. He had been the personification of the Soviet aircraft industry from the earliest days, respected by all Soviet leaders from Lenin to Brezhnev. Khrushchev once described him as a diplomat as well as a great scientist and scholar. He left a vast legacy for Soviet and world aviation. Fortunately, he did not live to see the Tu-144's moment of tragedy. At the 1973 Paris Air Show, a Tu-144 crashed under mysterious circumstances. On the last day of the show, Concorde had just finished its flight. Mikhail Kozlov took off in the second production Tu-144. The competition and pressure to make a good showing was intense. At 3,000 feet, the aircraft appeared to stall and dive abruptly. Then, it broke apart. It landed on a small French village. 8 villagers were killed. So were the 6 Russian aircrew. There was no satisfactory explanation for the accident, but it cast more doubt on a program that was already faltering. In November 1977, the Tu-144 began its long-awaited passenger service. The aircraft's performance was disappointing. It revealed that Tupolev designers had never really solved the problems caused by inefficient engines. The scheduled service was plagued by cancellations. Transatlantic route. In October 1977, British Airways and Air France Concordes flew to New York for the first time. The 70s had been a difficult time in which to develop supersonic transport. Fuel shortages and increasing environmental awareness had eroded the popularity and viability of the SST concept. The United States had aborted its program in 1971 on the basis that the SST was inefficient, expensive, and environmentally unsound. By 1977, the Soviet SST seemed to be heading for a similar fate. But the French and British remained undaunted. The champions of the Concorde insisted that supersonic airliners would have a major role in the future of air travel. As the two Concordes landed at Kennedy International Airport in New York in October 1977, they sealed the Anglo-French monopoly on transatlantic supersonic air travel. Within 5 years, Concorde would be the only remaining operational supersonic transport. It would be a winner by default. The Concorde would never be an aircraft for the masses. Its fuel consumption per passenger keeps it well above the price range of the average traveler. In 1963, it was predicted that supersonic transports would eventually dominate international travel, but so far at least, the realities of efficiency versus speed have prevailed. As the excitement surrounding the development of supersonic transports flooded aviation circles in the late 60s, a less obviously glamorous aircraft than the SST appeared. The remarkably efficient Boeing 747 would become the symbol of mass international travel through the 1970s and 80s. On the 6th of August, 1989, a new development of the basic 747, the 747-400, landed at Sydney International Airport. It had just made a non-stop 20-hour flight from London, the longest non-stop airline flight in the history of aviation. Range rather than speed was proving to be the way of the future. The last remaining Tu-144 now sits quietly among the birch trees surrounding the Monino Air Force Museum, 40 miles outside Moscow. The Soviet SST program was cancelled in 1982 after a disappointing 7 years of operation. Once expected to revolutionize air travel, the Tu-144 is now a relic of an earlier age when the power of the Soviet state and the potential of Soviet technological achievement seemed limitless. But the Tu-144 left a legacy which lives on in Russian aviation. This is the Tupolev Tu-160, the Blackjack. Its wing routes, landing gear, and jet engine intakes are developments of the Tu-144 experience. But Tupolev, the Blackjack, was a shift back to military aircraft, an attempt to take the lead in world strategic bomber design. Now, the Blackjack itself is being threatened, not by limitations of technology, but by the end of the Cold War between East and West. Like the Tu-144, its market is disappearing.